Okay, the next problem is an application of the conservation of energy. Okay, so let's take a look at this problem. We know the combined mass of the Zohr and Slat, and we know that the Zohr starts from the top of the hill with a vertical height of 2.5 meters, and she goes all the way to the bottom of that hill, and we need to find the speed of the bottom at the bottom of the hill, if we know that air resistance and friction are negligible. Okay, we know that the change of the kinetic energy plus the change of the potential energy, in this case only gravity contributes, is given by the work done by the non-conservative forces, and we are said that there are no non-conservative forces or their work is negligible, so this is 0. So the change of the kinetic energy is given by the initial kinetic energy, its mass times the speed squared in the final state divided by 2 minus mass times the initial speed squared divided by 2 plus the change of the potential energy. It is just given by mg times delta y, where delta y is a change from the initial position, so this is y initial and this is y final. So as you can see from this picture, delta y is minus h, or it is negative 2.5 meters. Okay, and this is 0. So we know that initially the speed was 0, so this is 0, and we have to solve this equation for unknown, and the unknown is the speed at the final state. So solving this for Vf, we will obtain square root of negative 2g times delta y. So what I've done, I divide everything by the mass, I multiplied everything by 2, and then I solved for Vf squared and took a square root. Okay, so, or, this is the same after the substituting the numbers, it's the square root of minus 2 times 9.8 meters per second square times, and delta y is negative 2.5 meters, times negative 2.5 meters. Okay, substituting the numbers and using our calculator, which I'm doing right now, you will obtain 7 meters per second, or the answer is D.